So, in part two of our discussion this week, you got a second periodic table. Well, this week, I know you have a million of them, but they all serve a purpose. And so, yesterday, you colored your periodic table according to the main categories: metals, metalloids, and nonmetals. But today, as you already know, we've started talking about reactivity and also valence electrons. And so in this portion, you are going to color your periodic table a little differently. But it's really important to know that yesterday you colored it according to metals, metalloids, and nonmetals. Today is going to be according to how reactive the elements and atoms are. So the first thing that I'd like you to do is at the top of your paper, write reactivity and give the definition. So the definition of reactivity is how likely one atom is to bond with another. So if something were highly reactive, it means it's very likely and easy for this atom to bond with another atom. So please write that at the top of your periodic table so that when you pull this periodic table out, you know that this periodic table is color-coded to each element's reactivity. And please pause this as needed. So if you need some time to write and I'm talking too fast, just pause it and then pick right back up when you're ready. After you write the definition of reactivity, I need you to get out the colors yellow, green, and red. And as you can see, we're going to color those onto our periodic table to designate 3 different categories of reactivity on the periodic table. And so yesterday during, or even Friday during the brain dump, you labeled down at the bottom that increasing reactivity on the periodic table went from right to left. So the most reactive elements were on the left and the least reactive on the right, which is true. There's just one exception. So what I want you to do is I want you to take your green first, and I want you to color in group or family number 1 and group 17. So those two should be green. And when you're done coloring them green, I need you to take your pen or pencil and at the top of each of those groups, label them highly reactive. So group 17 is an exception on this side of the periodic table that even though most of these are little to no reactivity, group 17 is highly reactive. And that's why we kind of do this like a stoplight, green being go, like highly reactive. They are ready to share their electrons with other atoms very easily, and it's not hard to do. So they are very likely to bond, and it's not hard. Then I would like you, when you're ready, to take the red and color in all of group 18, which from brain dump, you labeled the noble gases. Group 18 are the noble gases. After you color them red, label them unreactive or non-reactive. And you have also labeled at the bottom here that they are the most stable, which is true. So stable means they're not going anywhere. So because they're unreactive, they don't want to bond with other atoms. They are very unlikely to bond with other atoms. They're very unlikely to make compounds with others. They can, but it's very difficult. So the reason that these guys are very unreactive is because their outer shell of electrons is full already. And once it's full, they're happy. Every atom wants its outer shell or its valence electron shell to be full. So really, that's why atoms bond. They bond together to make compounds and to fill their outer shell. So all of the rest of these elements on the periodic table do not have full outer shells yet. When they bond with another atom, it fills the outer shell. And we'll talk more about that in a second. So group 1 and group 17 are green and highly reactive, and group 18 is red and unreactive, and the noble gases. They are the most stable. Please take your yellow and color in everyone else, including these two rows down here. So yellow just means it's in between. It's slightly reactive. So these groups are likely to bond with other atoms, just not as easily. So obviously, though, it becomes more likely as you travel to the left-hand side of your periodic table, where down here you wrote most reactive. So these guys are all in between. So when you're finished, your periodic table will look like this. And then I just kind of put a reminder here that the group numbers are these numbers across the top, the single digit 1, 2, and then the ones place here, 3, 4. That part of the group number, because it's group 13 and 14, 15, 16, 17, but we look at the ones place because from the brain dump, that tells you how many valence electrons there are in an atom, which we just finished talking about. Remember, valence electrons are the outermost electrons only. So for example, carbon has 6 total electrons, but there are 4 of them in the outer shell. Remember, there's 2 on the first shell and 4 on the second shell. So that means the 4 are the outermost. And the reason we have to focus on the outermost shell is because those are the ones involved in bonding. So when you're done, turn to the back of this and we're going to take some notes. And go ahead and start writing whenever you're ready. Remember, pause when you need to pause, okay? Because I also need you to hear what I'm saying while you're writing. But it says, reactivity. How do we figure it out? So when I'm asking you maybe in class or during a warm-up to tell me how reactive an element is, you can look at these steps. So write down step number 1. The first thing you do is look at the group number. This tells us the number of valence electrons. And I'm going to flip back for just a second. Remember that the group number is this number here, right across the top, and the ones place only right here, and that will tell us. So in group 17, if I look at the ones place, that's a 7. Everyone in this group has 7 outer electrons, 7 valence electrons. Everyone in group 18 has 8 valence electrons. Everyone in group 1 has 1 valence electron. So that's step 1. Number 2, if the atom doesn't have 8 valence electrons, which is everyone except for the noble gases, that means it's reactive. And then you just have to remember that groups 1 and 17 are highly reactive. It's probably hard to see on your paper, but I highlighted that green because those highly reactive groups on your periodic table, you colored green. And then for number 3, noble gases are not reactive. And again, I went over that with red because that red group of the noble gases is what you colored to show that they are not reactive on your periodic table back here. It says they already have 8 electrons in their outer shell, so they are stable. Stable means very unlikely to bond. They don't need to bond because they already have what they need. So really what you need to focus on with reactivity is the magic number 8. 8 valence electrons equals a full outer shell equals a happy atom. If they have 8, there's no reason to bond or be reactive anymore. Anyone who doesn't have 8, though, is going to be reactive. The one thing we do need to talk about, though, is why group 1 and 17 are highly reactive. So group 1, if you think about it, okay, 1 means it has 1 valence electron. 1 valence electron is very easy to give away. It's just 1. So when they're bonding, and we will have watched a reactivity video, the group 1 is very, very reactive. It's very easy to give 1 electron away. So it happens really fast, which is why they're highly reactive. Group 17 has 7 valence electrons. They only need 1 more to make 8, and it's very easy to just take 1 from someone else. It's easier to get 1 or give away 1 rather than 4 or 5 or 6. So I'm going to have you continue in the Nearpod. Please raise your hand if you have questions, and we'll move on from there.